morning, students. A very pleasant good morning to you all. Today in this session, we are going to discuss some of the theorems of circle. And the very first theorem is, if in a circle, two chords are equal, then they will subtend equal angle at the center. So, in the given figure, you can see that AB and CD are two equal chords. That's given to you. And you have to prove that the angles subtended by the chord AB and CD are equal. It means that you have to prove angle AOB is equal to COD. So, in triangle AOB and COD, we have OA is equal to OC. Equal radii. OB is equal to OD, again equal radii. And the third part, that is AB is equal to CD, is given to you. Therefore, triangle AOB is congruent to COD by SSS congruency criteria, and hence the two angle, that is angle AOB is equal to COD by CPCT. I hope you might have understood this theorem. The next theorem is, if the angles subtended by the chord of a circle at the center are equal, then the chords are equal. So, this is just the converse of the theorem just I have discussed. So, if the angles subtended by the chord of a circle at the center are equal, means AB and CD are two chords given to you, and they subtend equal angle at the center, that is angle AOB is equal to COD, and we have to prove chord AB is equal to CD. So in triangle AOB and triangle COD, we have OA is equal to OC, equal radii, OB is equal to OD, again equal radii, and angle AOB is equal to COD. That's because it's given. So the two triangle AOB and triangle COD are congruent by SAS criteria, and hence AB is equal to CD by CPCT. Now the next theorem, that is the perpendicular drawn from the center to a chord bisect the chord. That is, in the given figure you might have seen that OL is perpendicular to AB. Now, if OL is perpendicular to AB, you have to prove LA is equal to AB. Now, in construction part, join OA and OB. So, OLA and OLB are two right triangles because OL is perpendicular to AB. So, in triangle OLA and OLB, we have angle OLA is equal to angle OLB. It's because OL is perpendicular. OA is equal to OB. It's because the radii are equal. And OL is equal to OL. That's because it's common. So the two triangle OLA and OLB are congruent by RHS criteria, and hence AL is equal to BL. Next theorem is, this is just the converse of the theorem that I have just discussed. This says that the line drawn to the center of a circle to bisect the chord is perpendicular. That is, OM is joined to the midpoint of AB. You have to prove OM is perpendicular. So, it's given that in the given figure, you can see that a circle is given to you and chord AB is given, in which M is the midpoint of AB. To prove OM is perpendicular to AB, in construction part, join OA and OB. Now prove. In triangle OMA and OMB, we have OA is equal to OB, equal radii, OM is equal to OM, common, and MA is equal to MB, It is because M is the midpoint or it's given. Therefore, the triangle OMA is congruent to OMB by SSS congruency criteria. And hence, angle OMA is equal to OMB by CPCT, and OMA plus OMB is equal to 180 degree by linear pair axiom. So, OMA plus OMA plus OMA, because OMB is equal to OMA. So OMA plus OMA is equal to 180 degree. So 2 OMA is equal to 180 degree, or OMA is equal to 90 degree. And therefore we can say that OM is perpendicular to AB. That's all.